Okay, so there's going to be a few main takeaways from our lesson today. One is we're solving for everything. So you have to determine what you're solving for, and that's a big part of figuring out what the question is asking, what you're subbing in for, what you still have to find, that kind of thing. In some cases, it might be straightforward. In fact, the first two examples are more examples of similar to the ones we've already done. They might be the hardest to determine what you're solving for. And we talked about this a little bit yesterday, how sometimes the wording can be a bit awkward or can be a bit confusing. And so, like I said, that's one of the big takeaways from today is what are you solving for? Specifically, is it present value or future value? Um, However, the other takeaway, one of the other takeaways, is we're going to use technology. So we're not going to be using our calculators. We're going to use an app that we're going to access through the Google Classroom, and we're going to use that to solve. So that's going to make things a little bit more awkward in terms of how we format our answers, but we're not going to really overthink that or worry too much about it. We're just going to have a bit of an experience about solving for other things in um, the compound interest formula, and hopefully it gives some indication of how there are all kinds of different scenarios that you might be interested in solving for um, time or solving for an interest rate or something like that. And these are, again, as we talked about, real world problems, things that people would do all the time. You could definitely imagine somebody sitting down and saying, I have to get this loan, and in order to afford it, I need to get an interest rate of whatever X percentage, right? So that's kind of going to be another one of the takeaways from today. So on that note, we have to figure out how to use this technology. So that's what we're going to start with. So the first thing you want to do right now, get your device out. It will probably work on a phone. It's better on a laptop or a Chromebook. It'll be a little bit tricky on a phone just entering the numbers, but you can manage, I'm sure. Okay, and go to the lesson for all types, and you should see this link at the top. And if you have to pause the video, obviously do that. I'm going to try not to go too fast, but hopefully you'll be able to see what happens on my screen when I click this link. It comes up with this page, and you want to make a copy. Now, we're looking at this little box. The general idea about how this app works is only change the numbers in the boxes that are colored blue, so don't touch anything else. If it stops working, if something messes up, then you can ask or you can just undo. Or you can go back to the Google Classroom and make another copy and just start from scratch. Okay. Uh, and then you can see at the bottom here, the first tab is for future value. So that's what we talked about for the first time when we did compound interest. And then we talked about present value. So if you were doing a present value question, you have to use this one. If you're solving for time, which is one of the examples we're going to look at, then select that one. And then there's one fun, and really you're not going to use the present value version. You're only going to use the future value version. Okay. And then if you're solving for the rate, like the example that I just gave, you're going to use that tab. So there's 4 tabs along the bottom. And again, you're not really going to use present value. You're going to use future value. And again, only change the boxes that are colored blue. Okay, so let's see how this works. Billy is saving for a down payment on a house. He wants to have $40,000 in 5 years. He can invest his money at 3.8% compounded monthly. How much should he deposit today to meet his goal? So our first thing that we're going to analyze when we start this question is it present value, future value, or something else? It's not something else. We're going to start with the same kinds that we've been already working with. But when is the amount of money that we're solving for? Is it happening earlier or later? So he wants to have $40,000 in 5 years. That's happening at a later date. So that means this is a present value question. Okay, so again, I'm using this notation, present value and future value, and you just have to make sure that you have the negative n as your exponent. We're going to list our givens. Again, if you want to pause the video at any point and try the question yourself, this is something that we've already done. So you can probably get it set up, then go ahead and do that. So present value is what we're solving for. 40,000 is the future value. That's the amount that we want later on. I, again, is the interest rate as a decimal divided by the compounding period. And n is the number of compounds, which is the number of years, 5 years, times compounds per year. So there's going to be, in this case, 60 compounds. So I am going to sub this in just because it's good practice. But what we're going to do is we're going to try using the technology, the online calculator, or this applet to do the calculation for us. If you want to try it on your calculator as well and sort of verify that it gives the same answer, that's not a bad idea. But you can rely on this applet to work and give us the right answer. There are lots of online calculators, financial calculators. I think every big bank or every financial institution has their own. Some might be a little bit more user friendly than others. There are lots that are just available online as well that aren't part of a bank or anything like that. And some have more functionality, which means it might be a bit more complicated. It might be a little bit harder to figure out. But in your future, someday, if you're ever trying to solve these questions, that's what I would recommend. I would strongly recommend find a calculator you're comfortable with that's online and just use that. You'll see how absolutely easy they are to use when we do this first question. So this is a present value question, which means we have the future value, which is 40,000. So we'll put that in. Our interest rate is 3.8%. Now, what's important to know is this wants the interest rate, not the value for I. When you put in the compounds per year, which is already 12, so I'm just going to leave that alone because ours was also 12. It's going to calculate I on its own. So it's doing all that work for us. And this was over 5 years, so we're going to change that to 5. And there you go. It gives us the present value. That looks reasonable, 33,000, right? We've talked about this. It's hard to know exactly what the value should be, but that's a reasonable answer. It's smaller. That's important. Present value should be smaller. So we know that we didn't use the wrong formula or use the wrong tab if we're using technology or enter the numbers in wrong. And the other thing to notice, which this question doesn't ask about, but in some of the practice questions you would have noticed it came up, how much is there in interest? So it calculates that for you as well, which is something that is very important to people who are making investments or buying a house, paying off their mortgage, they want to know how much interest they're being charged on a regular basis. Okay. So 33088.30. Now, the other thing that I just want to say, we've talked about this a little bit, but um, you know, we're just exploring compound interest. If you were actually saving up for a down payment on a house, it's more likely that you might have a chunk of money that you can put away today. A lot of people, especially if they're younger and they're buying their first house, they don't have $30,000 that they can just put into a savings account. So some of these scenarios that we're going over are not the most realistic. It's more likely that you would put away $50 every paycheck, right? So most people get paid every 2 weeks. You might put $50 away every 2 weeks, or $100 away every 2 weeks, or whatever it is, right? And that's a very different kind um, uh, of a formula. It's called an annuity. We talked about this briefly, right? And there are special annuities like mortgages. So it's a different formula. It's a totally different type of relation, and it's a much more realistic one. If you're saving for retirement, or you're saving to buy a car, or saving, like I said, saving up for a down payment on a house, it's more likely that you're making regular payments. It is just a different formula, and again, there are websites, technology that will absolutely just do it for you. So in in your future, in your real life, that shouldn't be a problem. The math isn't going to be harder because you can just punch the numbers in. Um, but that is a more realistic situation. That being said, because we're only talking about compound interest, that's sort of the situation that we're dealing with. Okay, so if Billy deposits $33,000 today, it will be worth $40,000 in 5 years. Okay, next one. Graham gets a large bonus at work and as a reward for having a great year. So he takes a portion of his bonus, $34,500, and invests it at 4.9% compounded quarterly. His plan is to eventually use this money for a down payment on a house. How much will he have in 5 years? So a similar situation, but again, if you compare example one and example two, I hope you can see how one gives you that amount that's in the future and the other one gives you the amount now, and it is going to grow to a new amount. So this is a future value question. And all I can say is that even if these two are fairly straightforward, there absolutely are types of questions that can be confusing and that you can mix up between present value and future value. And this is true for annuities as well. So if you do take grade 12 math and you end up working with annuities and mortgages and that kind of thing, it's the same thing there, that there are some questions that are just worded in a weird way and you can get the wrong formula. So it is something worth really taking some extra time to think about. Okay, so again, if you want to set this up yourself, go ahead. So quarterly, which means we're dividing by 4, and means we're taking the 5 years and multiplying by 4. And again, we're going to use our calculator. 4.9%. For compounds per year because it's quarterly for 5 years. There's a weird quirk, and this is just a Google Sheets thing. If you put the rate in a weird way, I think it's if you type 0.05 instead of 0.05, it changes the formatting and it really wrecks something. So I think that's what it is. It shouldn't be a major problem. There might be one question coming up that we're looking at. I'm not sure if it's in this lesson, where it messes up the formatting. So if that happens and you're getting answers that are weird, or if the percentage, the interest rate doesn't look right, I would just say try to undo, or like I said, go back to the Google Classroom and make a new copy. But otherwise, hopefully, everything else is pretty user-friendly, works pretty well. So it looks like in this case, $34,500 is going to go to $44,000, a little bit more than $44,000. Okay, so he'll have $44,012.37. And, in 5 years, that's a $10,000 or almost $10,000 increase. It does kind of show that at a semi-decent interest rate, 4.9% is not something you're getting in a savings account. We talked briefly about different kinds of investments, but there are definitely investments out there, longer term investments, but even maybe over 5 years that you could get that kind of an interest rate and get $10,000. And this is exactly the kind of situation where, if you ever find yourself in a similar situation where you get some kind of a big bonus or some kind of maybe it's an inheritance or who knows, and you get a chunk of money, you can see how you can make your money work for you and you can make it grow over time. And it's a really, really good idea to do that. In the long term, in the long run, you're really going to benefit from it. All right, two more that are a little bit different. Andrea currently has, this is where when we set it up, we're going to set it up in sub-in. But there's a little bit of a discrepancy between how we're going to set it up and how the answer is actually going to work. But because the technology is going to do it for us, we're not really going to read into it. Okay, so don't overthink any of this. Andrea currently has $900 in savings. She can invest it at 8.5% per year, compounded monthly. She needs $1,100 to buy the car she wants. How long will it take until she can buy the car? Investing at 8.5% is definitely something that is a kind of return that you could achieve. Probably not in the short term, which I don't think this is going to be a long-term investment. So again, this might be a bit of an unrealistic situation. But also investing $900 and hoping it to grow to $1,100 is not that realistic. But we're trying to keep this with sort of numbers or situations that we might be able to envision ourselves thinking about. Buying a car in the next few years for anyone is probably not going to be like a $40,000 car. So we're looking at some kind of used car. So it's more realistic that it would be about $1,100. Anyway, these questions, first of all, we have to decide what we are solving for. How long will it take? So we're solving for time. Okay, so you could use either present value or future value, but we're just going to use future value for all these different kinds of questions. And again, we're going to list all of our givens. So in this case, we're solving for time. So n is what we're solving for, but n is the actual number of compounds. It's not the number of years. So this is that discrepancy that I was talking about. Don't overthink it. Don't worry too much about it. We're not worried about the form here. It's a little off. But the applet that we're using is going to just give us the final answer. Okay, so it's going to give us the number of years, and that's what we're looking for. But n is the unknown because we don't know the number of years. We do know the compounding periods. We know that part of it, but we don't know the number of years. So n is still kind of what we're looking for. So future value is 1100. Present value is 900. I is 0.085 divided by 12. And, again, we're subbing in, but we're not really doing anything with this equation. So this is an equation that we have solved and that you could solve. Divide both sides by 900. You would have to figure out what 0.085 divided by 12 is, and I think that would give you kind of a nasty decimal, so you'd be doing a little bit of rounding, but you could get a ballpark answer with the methods that we used in the previous unit. But let's see what happens when we use the applet to solve for time. So again, I'm going to go to future value, 1100. Present value, we currently have 900. 8.5%. Compounds per year is 12. I put those in backwards. That's why it's giving me a negative. Sorry, let me go back and fix that. That's an interesting development. Notice that it said negative 2.4 and now it says 2.4. So that indicated to me that I had those backwards. The initial amount is 900 building to 1100, right? And so getting a negative value when you're working with these kinds of math equations is actually a common either mistake or actually some technologies just give you a negative for that reason. So it's something to be aware of. But now that I fixed it, it gives us the right answer of number of years is 2.4. So I'm just going to go back. And I'm not going to say n equals 2.4 because technically it's not n. It's the number of years, and n is the number of years times the compounds per year, so it'd be 2.4 times 12. So I'm just going to make a final statement. Therefore, she can buy the car in 2.4 years. And again, realistically, she would probably be also depositing money into that account throughout those years, hopefully. It's not very often where you would have $900 and you just put it in an account and let it sit there. But anyway, we're trying to just learn the math here and learn a little bit about how to use technology to solve these problems as well. Not too worried about the realism. Okay, example 4 and last example. Derek is planning on attending college in 5 years. He currently has $6,500, but he needs $8,000. What interest rate, let's assume it's going to be compounded monthly, does he need to invest to meet his goal? So this one's looking for rate. Okay, and again, we're just going to use future value. So future value is going to be the big amount. Present value is the small amount. And again, I is not just the interest rate. It's the interest rate divided by the compounding period. So in this case, divided by 12 because it's compounded monthly. So we are looking for I, but the technology is going to give us the actual rate, but we're not going to overthink it. I'm just going to write R equals question mark because that is really what we're looking for. And 5 years compounded monthly times 12 again is 60.